Hello, this is a quick tutorial of this Slitscan effect on COPs. We're going to go through importing an image sequence as a volume in 3D space and then how to sample that in COPs to create these cool time offset animations. The whole setup was inspired by this guest tutorial from Stefan Helbing made for Entagma, where he goes through the process of slit scanning in subspace. And we're also going to be using this approach from Konstantin Magnus to import image sequences as a volume. Let's take a look at the setup now. We're starting off by initializing a volume. The important thing here is to set it to vector float so that we can sample our color data. In the VDB activate, we can basically set up the size or resolution. The X and Y axes are the image resolution and the Z axis is the length of the sequence. The Game Boy animation basically has 148 frames, and that's why it's set to 148. We then fit the volume to -1 world space. As you can see here, -1 1 -1 1. And that just makes it a lot easier to read out the data later on. And then we get to the volume wrangle, which is basically stolen from the Konstantin Magnus video. What we do here is we take each image of the animation and give it to one of the slices in the Z direction. So we look at the sequence length. We go through it, we map the Z position to the sequence length, and then we read each frame and fill each voxel with the color on the corresponding pixel, and basically just write that out to the volume. And if we take a look at the volume through the volume visualization node, we can see all of the frames lined up with color data, and we can then take a look at how to import them into COPs. It's basically just a Geo to VDB node, and you press set imports from geometry and it sets it up automatically. And we then pipe the color data into the OpenCL sampler node. And if we look at the sampler code, we can see first off code to bind all of the input ports. We're then initializing a position vector, which is basically just the screen coordinates. If we take a look at this vector, you can see it just goes from -1 -1 to 1 1. And we're using that position vector to sample the VDB, which is in here. And we're using the world sample function, which basically samples the VDB in world space. And since we've set up the volume beforehand to go from -1 to 1, we can just use this position, which also goes from -1 to 1, to sample the coordinates. And if we take a look here, we can see this is the frame on Z-axis 0, because this returns 0 on the Z-axis. But what we can do now is just put a different value in there, for example with the slider up here. I don't know why my viewport is bugging out, but you can see it's sampling the image sequence in time. And the cool thing about this technique is we don't need to use a slider to sample the Z index. We can also use any input texture, for example this gradient. I just pipe that into the position input here, and we're going to sample it from there and map it to our Z-axis. And that's basically how we achieve the slit scan effect. I hope that this was somewhat useful for you and you have fun playing around with the example file. If you want to dive a little deeper into the topic, I've also included a paid version where you have access to this file loading HDA, which takes an image sequence and spits out a volume to sample from. And there's also some other techniques, including UV sampling, where it's basically combining the sampling in time with UVs to position the offsets in space, which is also a lot of fun to play around with.